Hello everyone. Today we will be making this little flexible tube, somewhat flexible, and we are making this to fix a broken piece of equipment that I have laying around. This guy right here. As you can see, I already fixed this, but I didn't get a chance to capture all the details doing it while I was taking this apart. I do have a bunch of images and photos that I will share as we going over this, but basically what was happening, a tube inside that goes from a brush down into up into a vacuum was broken. It deteriorated, had a ton of vacuum leak, and if you ever saw one of the tubes that originally come with it, it's basically a metal spiral inside of a sleeve that is meant to be flexible, so the vacuum cleaner can operate as. Again, in the spirit of trying to fix things instead of just going out and buying a new vacuum cleaner for a few $100, decided to save this little piece of equipment. Um, and I can already tell by testing this that this little tube that will take us about 10 minutes to model fix the issue. No more vacuum leaks. It works well. Um, Functions well. It's not as flexible, but it does the job really great. So with that, we'll jump into our first step, making some basic measurements. As I said, I've already fixed this, but I'm going to show my approach how I did this, and we'll go from that point. We want to start off with a basic sketch of what basically is a spring inside. So this is a cross section, and I measured this 3 millimeters. So this is basically this right here. If we were to cut this, slice this open, this little rib is our 3 millimeter diameter. And now what we would need to do is basically we would want to extrude it in this type of coil, right? So what we need to know is we will basically have we'll have something that will look something like this, right? And off it goes. I apologize for somewhat rough sketch, but the idea is to really just take rough measurements, right? So what we will have is then a tube inside that rib, and this should in the end look something like this. We know that our what used to be a spring, we cannot obviously put a metal spring inside, so I am using my TPU flexible material to build up the tension in this section. And while making this section as thin as possible for flexibility, right? So this here was one of our tests, and this was too thick. As you can tell, when I try to turn it, it collapses, and which means what happens as a result, it blocks the air pathway. This is why this is not the final version that's currently installed. This one was just too thick, the wall thickness, and this wall thickness is only 2 layers thick. So when I tested it, I realized this material is not flexible enough. So as a result, what we're doing, we know that this dimension here is 31, and I know that my tube approximately, because I can always cut it short, I'd rather print it longer than needed. I need at least 180 millimeters long, right, to have enough. And as I said, I cut off some extra section off. At this point, I have only one dimension that I still need, and that is this here, right? So that is approximately 30. I believe it's about 33, 32, 33. Again, this is relatively flexible, so I can work this inside the tube. Okay, so we have our sketch. We have our spring cross section. We have the cross section of the diameter and the length of the tube. Now we will jump over into our FreeCAD. Okay, so we start off with a sketch, and we begin with a cross-sectional area. Again, my approach, start your sketches at the origin. D for dimension, and my radius is diameter, it's 3 millimeters. Now I have a little bit of an issue that I will run into. Because I put my coil at the origin, my center point of the tube will be somewhere over here or here. I do not like that approach. What I will do, I will instead put my coil here, give it a dimension, and then I will say that we mentioned that our distance, our tube was 31, right, and roughly 33 for a outside dimension. So 33 divided by 2 will be 16.5 center to center, right? But then I have to also account for this is 16.5. I wanted 16.5 to the outside, so I will then subtract 1.5 for a radius. So now it's 15 center to center. It will be 16.5 to the outside, right? As you can see, sketch turned green means it's fully defined. We can close the sketch. So there's our cross-sectional area of a sketch, right? So now what we want to do is tell this circle to extrude in a coil, and we can do that by using this subtractive this here, additive helix. Okay, this here is a little bit rough, not really what we looking for. So what we need to do is adjust a few parameters. First one being, we didn't measure it, but I know based on my test print, my previous testing that I've done, that my pitch is, and pitch, if similar to how the screws and threads on the bolts work, pitch is the distance from one high point to another high point, right? So if you think about this distance right here to this distance right here, that's our pitch. And in my case, the pitch was 10 millimeters. Okay, so again, doesn't really look right, and that is because we want to change the height to 180. Okay, there we go. So this here represents our tube. So this is a tube without a shell, right? So it has no shell inside. So basically it's our spring, and that is it. Let me do a quick adjustment for visibility. Okay, just the colors I like. Okay, so now how do we add the shell to this, right? We need a tube. As of right now, this tube is not leak proof. It's not gonna give us any vacuum. So we need to turn it into a tube. Create a sketch. Now we can throw a sketch on at the origin. And another one like this, right? So this will be our tube. We know that our center point for the tube is roughly 31, or the diameter is roughly 31, so I will do 31. And then I'll go half a millimeter, 0.5 millimeters in thickness on the radius, right? So my thickness has to be 31, which means that the diameter of inner circle versus the outer circle needs to be 1 millimeter difference. So we'll do 30. And we will switch over to this view, right? So this here is now our layer. And the reason I'm doing a half millimeter thickness is because my nozzle of 0.4 millimeters will not print. Basically, the slicer will say, hey, you do not have enough thickness to print a wall unless it's something like 5 millimeter thickness, because I think the nozzle is set up to print initial layer 0.42 to something of that nature. So 0.5 should work. Okay. So we close our sketch, switch our view, 36, there you go, for some reason. All right, so now we take this sketch and we extrude it 180 millimeters. There we go. So we now have a nice tube with some spring inside. What I want to do is I do want to trim off this little axis here, because one of the areas inside the vacuum brush is flat, and it needs this part to be flat. So all I will do, I will select this face, go to the top view, create a sketch. I will give it basic dimension that is larger, so we'll do 35. We will close it, we'll cut away, and all we're going to say is through all. Reverse direction, right? Through all, there. Good. And this here is our tube. That's it. It gives us what we need. Next, we will jump into a Bamboo lab studio to print this. Okay. We have our part. Looks great. Now, what I will do, I will flip this upside down. I trimmed this top section also because it will make it much easier for now to lay this tube flat onto a print bed. I have to print it vertically like this. Again, I am printing using a TPU material, my Inland TPU green. Great material, love it. very nice and flexible, relatively easy to print. I have this again calibrated. I ran a few tests, not on this particular part, but different shapes and sizes to really dial in the speed. What matters when you print is the speed. So if I go to the settings of my printer filament, which I'm trying to see right here, I have a volumetric speed set for this material as well as the temperatures. And Bamboo Lab printer does the rest pretty well. So as you can see, prints it nice and clean. Very little oozing from this material, which I love. This had no cleanup. The one part that I do want to add is a support, and specifically the raft. So I want to add one layer of raft material. What that does, it will add a little bit more footprint to our print, because this contact surface is extremely small. So this part will print for a few hours, and I don't want to get it to some few final layers of printing and it tip over, because that will ruin your whole print. You have to restart again, and it will typically happen almost at the end of the print. So if I slice this, it adds this little raft, which just creates extra contact surface. This is extremely easy to come off once the print is done, but again, it will save you from, the printer moves so quick when it prints. This is a bed slinger, what they call. So the bed moves with a part on it, and when it moves fast enough, it can actually tip the part over, and then you have to start over. It will take us 2.5, almost 3 hours to print. So we will save this and send this over to our print. We will come back. Well, we already know what the parts looks like. I will show a little bit of a 3D printing footage to show the real-time speed at which it prints. I hope this video helps give you some ideas how you can utilize 3D printing, CAD modeling, to create your own things, fix your own things. And thanks for sticking around. We will see you in the next video. Bye bye.